Arigato gozaimasu. Thank you very much. Konnichiwa. My name is Daniel Bohannon, and today I'll be talking about PowerShell obfuscation techniques and how to try to detect them. A little bit about myself. For the past year and a half, I've been doing incident response consulting with Mandiant. I'm based out of Washington, D.C. Before that, I spent 5 years doing operations and IT security for a national restaurant franchise in the U.S. So I am a blue teamer. I wouldn't call myself an official red team consultant, but I have been getting more exposure to the red team as part of this research. Really, what I'd like to cover today is looking at motivation. Why did I start researching PowerShell? And then we'll look at basically preparing your environment for investigating PowerShell attacks. Then we'll look at a really in-depth obfuscation example of PowerShell, particularly what's called the remote download cradle, remote download command. We'll look at some additional layers of obfuscation we can apply to PowerShell commands, and then more obfuscation techniques, how to try to detect those layers of obfuscation, and then looking at some more uncommon encoding, decoding, encryption techniques, some that we've seen attackers use and some that we've never seen before. And then we'll look at, lastly, some obscure launch techniques, basically ways to launch PowerShell code that would perhaps be surprising to you as it was to me in terms of where PowerShell command arguments are found, which I think is important as defenders to be aware of so we know where to look for malicious PowerShell. And then lastly, I'll give a brief demonstration of a tool that I wrote called Invoke-Obfuscation. This is an open source tool. It's available on my GitHub, and it basically packages together all of the obfuscation techniques that I'll be talking about in this presentation. So motivation. As an incident response consultant, there are rarely incidents that we investigate where PowerShell is not used at some point in the attack lifecycle. Script kiddies use PowerShell. More advanced attackers use PowerShell. A lot of common frameworks use PowerShell to launch payloads, oftentimes executing only in memory to get around AV and application whitelisting. We see PowerShell launch from a number of different locations, sometimes stored just as a script file or link files or registry, things of that nature. And at the end of the day, as defenders, we could say, okay, well, we just need to make sure that we're looking for command line arguments for whenever powershell.exe is launched. But that's not always the case, and that's what we'll look at here today. So the current state of detection, a lot of tools, a lot of techniques do just that. They look for whenever powershell.exe is launched, what are the command line arguments? And the two biggest things that we see attackers using are this encoded command, which allows you to have a base 64 encoded command, and also this remote download cradle, this remote download command. These are the two things that we see attackers use most often in our investigation. But what's important to remember is that this is not the only way to write these particular commands, and it's also not the only way to perform the same functionality. There are more ways to perform base 64 encoded commands. There are more ways to perform remotely downloading content into memory, and that's what we'll be looking at here. So know your options. PowerShell is a very rich language. There's just so many options that you can use to perform these similar tasks. It's important as defenders for us to be aware of those options before we even start to look at ways to obfuscate all of those options. So that's what I started doing. I started taking these simple commands and looking at our current detection techniques and saying, how can I remotely download content that doesn't use that command right there, that breaks our detection? Once I find a way, I'll document it, and then I'll update our detection to look for that new way. And I started to build out this portfolio of all these different options and how we can begin to detect it. And my hope is that this will benefit you all in a similar way, that you can see these options and start to look for them in your own environments. So that's my goal for the blue team, awareness so that we can adapt, so that we can become better at defending our networks and detecting malicious activity. For the red teamers, the pen testers, I hope you find this helpful in your engagements to bypass current detection for the ultimate purpose of helping that organization, maybe it's yours, maybe you're a consultant, but helping that target organization to become aware of how they didn't detect so that they can better detect going forward. And lastly, my last goal is just to introduce you all with the open source tool Invoke-Obfuscation, which my goal is to make all these obfuscation techniques extremely simple to generate so that you can test your own detection capabilities. So preparing your environment. I have one slide on this. This is worth a whole talk in and of itself, and it's probably the hardest slide of this entire presentation because it's not easy for most organizations to do. At the end of the day, the bare minimum that we really need to detect malicious PowerShell usage is command line arguments. Whether that is through a real-time agent or through event logs, we have to have command line arguments or we have almost nothing. In addition, the last point there, PowerShell provides really, really, really good logging in later versions. So starting with PowerShell version 3, we have module logs, and in 4 and 5, we have what are called script block and transcription logging. My colleague, Matt Dunwoody, has an excellent blog post on this that outlines all of these different logs and their value, so I highly recommend that. So let's look at an example. This command up here is probably the most common command that we see attackers using. This command will remotely download a PowerShell script into memory and then execute it on the target system, never creating a new file on disk. And attackers use this because a lot of common tools use this. It's the one that most people talk about on blogs and forums. It's the most common syntax that we see. So let's play red team versus blue team here. We have our red team attack command on the top. As defenders, how can we detect when this is run? When we see this on the command line, what are strings that we can use to detect this activity? Well, we could say if we see invoke expression and new object, system.net.webclient, and download string. If we see all 4 of these together, then that would catch this remote download command. So now, let's start obfuscating. And let's start looking at all the assumptions that we just made about this and how that can be dangerous. And let's get to the very core of what we can use to detect this activity. So first, whenever you see system.anything in PowerShell, it's typically referencing a .NET class, and system. Isn't necessary. You can remove that. The command works just fine. So we'll remove that from our attacker command, and we'll remove it from our detection. Next, the URL is a string. So we can actually concatenate. We can piece together that string. We can use double quotes. We can use single quotes. We can even add as much white space as we want. So let's just go ahead and remove HTTP from our detection. Next, we have download string. So this is a member of net.webclient. However, it's not the only member. It is the most common, but we've seen attackers use download string, download file, and even download data. And there's 9 that are listed right here, but there's actually even more. So again, we have to know our options. What is possible in the language itself? Are we looking for all of those options? So why don't we just say .download? We'll just take that as our indicator. The parenthesis, that doesn't have to be there. How? Well, we can set new object net.webclient as a variable, just like in this example here. So we'll just remove that parenthesis, so now we have .download. So again, download string is a member token. How can we obfuscate this member token? Well, as I was looking at this command, I started this research a year ago, and I started to say, well, how can I manipulate this command so that it looks weird on the command line, but it still executes properly in PowerShell? So I found is that you can put single quotes around a member token. So now that .download, we can't even rely on that. We need to remove that dot. We can also add double quotes, And I want you to look very closely at download string at this next slide, and I promise you this works. If we add a tick mark, that works. Now, why is this important and why does it work? Well, it works because the tick mark is an escape character for PowerShell. And typically you'll see it used before a 0 or before any of these 7 letters. A lot of times you'll see tick in for new line. However, we can throw ticks. We can put ticks in front of every letter that's not one of those, and our command works. And actually, the letters N, A, T, R, N that's left, if we uppercase it, we can throw ticks in front of those as well. So now we can put tick marks in front of every letter we want to for members. Now this is important because these tick marks persist in both command line logging, live command line information, as well as on the bottom screen you see PowerShell's script block logging, which removes all the layers of obfuscation except for this, and except for our string concatenation. So it will log all of the levels of encryption, of encoding, anything that you invoke with Invoke-Expression or Invoke-Command, it will show that, but we're not actually invoking this. So this actually remains in PowerShell logging. So as defenders, if we're looking for download string on the command line, then we know that there can be tick marks that can mess us up. But are we aware that those tick marks are also present in PowerShell logging? So, again, that was just for download string. Open read is another option we have to read in the payload as a byte stream that we need to be aware of. In addition, we can treat a member as a string if we add a .invoke afterwards. And by the way, all these slides will be published after this talk, both English and Japanese. So there's a lot of information here, and so I'll try not to talk too quickly, but again, all these slides will be available online with all these examples. All right, so let's just remove download from our indicator list. Is that all right? So now we have those 3 terms. So net.webclient. This one's easy to obfuscate. We can use tick marks. We can piece it together as a string. We can also set it in many variables and join it back together. So we'll just go with the first one. We'll use tick marks. So let's just remove that from our detection. So now we're left with Invoke-Expression and new object. So again, PowerShell is a very rich language, and for a lot of the commandlets, there are many aliases you can use for that commandlet to make it easier to write code. New object actually doesn't have any aliases, so I figured this should be pretty easy to detect. It should always look like new object, right? Not quite. There are so many commands in PowerShell that sometimes you forget which ones are available. So there's actually a command called get command, which will show you all the available commands. And this is nice because we can say, show me the commands that start with new -p wildcard. There's all the commands. Now, PowerShell doesn't return text. It returns PowerShell objects. So this means that if we return a single object, we can invoke it, like we're doing here. We can use Invoke-Expression, or we can use the ampersand or the .invoke operators. And now I want you to look very closely, because remember how we were able to use wildcards to search? So we can actually use wildcards, and now that is new object. That's the exact same as if we type new object, as is that. And we can keep going all the way. Now this is new object. Crazy, right? So now, if we're looking for new object on the command line or in script block logs, you'll never see it because that is it. In addition, get command has its own alias of GCM. And it actually has an undocumented alias of command. Now, why is command an alias? Why is it not documented? Well, it kind of is. So in PowerShell, when you type a command, it will automatically prepend a get dash to see if there's a commandlet named that. So now you have get command, GCM, and command. Do you think triggering off of command may generate a lot of false positives? It will, and I know from experience. Command is an execution flag as well, so you have to start thinking of all the possible places where this string could be and how detecting it can be problematic. There's also, with PowerShell 1.0 syntax, you can do the exact same thing with get command, get commands. And again, this will be in the published slides to go back and look at that. But again, we have to know our options. There are so many ways to do this in PowerShell, which is sitting on top of .NET. So many options. So let's go with this one. Let's go with GCM. So that's new object now. So we're left with just Invoke-Obfuscation. And I should say, in addition to get command, we can do the exact same technique with get alias, alias, and gal. Only we're dealing with the shortened alias, not the full command name. But they still work. In addition, we could just put tick marks in front of the commandlet. And there's this great thing called splatting. So splatting allows me to treat a commandlet as a string and then invoke that string to invoke the command. So do we want to regex this for detection or just get rid of it as an indicator? Well, it's going to be a very complicated regex, I can assure you, because I've written it as best I can, and it's terrible. Very complicated. So Invoke-Obfuscation. This is actually a really, really good indicator, even just by itself. If you see Invoke-Obfuscation or IEX on the command line, it's definitely something to look at. So what's problematic about Invoke-Obfuscation? Well, again, it has an alias of IEX. Ordering, you can have it at the beginning or the end of your expression. You can have tick marks in front of the commandlets. You can do splatting, so now you treat the commandlet name as a string and can start to manipulate it. And then you also have this thing called invoke command. Now, typically invoke command is used if you want to run a command on a remote system. However, if you don't specify a remote system, it runs locally. And invoke command is very rich. You have invoke command, ICM, you have .invoke, and then you have the ampersand and .invoke operators. Now, the biggest difference between Invoke-Obfuscation and invoke command. Invoke-Obfuscation is expecting a string, an expression. Invoke command is expecting a script block, which typically is denoted by curly braces, as you see in the examples here. So as a defender, how are we going to alert if we see a period or an ampersand? It's impossible. We can't possibly do that. So what if we try to reduce false positives by saying we're interested in Invoke-Obfuscation, invoke command, and if we see a dot or an ampersand as well as curly braces, then that's interesting as well. Well, that works most of the time. However, you can actually cast or convert strings to script blocks. And again, I know this text is small, but it's in the slides to go back. But with .NET and with PowerShell 1.0, you can convert an expression into a script block. So now you have a script block without curly braces being used at all, which again makes monitoring for that ampersand and dot operator much more difficult. In addition, you can obfuscate these commands that are used to cast an expression to a script block. And when you do this, what you'll find is that the entire command is now a string. So now you can, after you obfuscate the member token, the commandlets, arguments, anything, you can take that command and invoke it and take that command out and treat it as a string and now perform like layer 2 obfuscation. You can start to concatenate the string and reorder it or reverse it or do all kinds of things we'll look at briefly in the next slides. Here's an example of the .NET version being obfuscated. So this is our original command now. None of our strings we used at the beginning work. And this is only looking at one example. This is looking at net.webclient for remotely downloading content. So let's step away from the obfuscation and go back to the richness of PowerShell as a language. What additional methods do we have for remote download? Well, with PowerShell 3.0 and later, they give us some new ones. They give us invoke web request and invoke rest method. I've seen attackers using one of these before. In addition, with any version of PowerShell, you can still call a lot of these classes directly in .NET. And again, system dot isn't necessary. We have seen some attackers using these as well. The syntax on the right is for converting the byte stream back into an expression before it's invoked. But what about if you're an organization who, let's say you're monitoring for whenever powershell.exe makes a network connection. That would work, right? It wouldn't matter what syntax you use. If powershell.exe makes a network connection, I'm interested in that. So let's say that you're doing just that. Let's say you're using sysmon event logs to look for PowerShell making a network connection. As an attacker, what if we do something like, I don't know, open up Notepad, and let's go open a file, but instead of typing in a file, what if we type in a URL? And if we open Notepad, we'll go retrieve the contents of that URL. So how can we automate this in PowerShell? Well, PowerShell can access this class called SendKeys, which interacts interactively with an application. So this code, this launches Notepad. It then sends the keys Control-O to open. It then sends the keys of the malicious URL, hits an enter key, waits a couple seconds, then sends Control-A to select all that text in Notepad, Control-C to copy it, and then the last portion at the bottom is basically pulling that command out of the clipboard and then invoking it. So in this example, PowerShell never made a network connection. Notepad did. And with most things in PowerShell, when PowerShell makes it easy to do something, it's typically to give additional visibility to PowerShell in the event logs. So at the very top is the example we just did with SendKeys. Well, you can actually do all of that without calling the PowerShell kind of wrapping commands. You can call those directly in .NET. And if you do this, if you'll notice these void functions at the beginning, if you can get void in front of that command, it won't even show up in PowerShell event logs. So just a technique to keep your activities quiet. But again, from the blue team perspective, if I ever see a void on the command line especially, that should be very concerning for me. And again, just to show there's so many ways to accomplish any single task. Again, SendKeys, we can use this syntax, and there's many, many more options. And this really works with any application that has an open file GUI functionality. So this is kind of a fun example, but most users would probably become suspicious if Notepad opens up and starts downloading scripts and executing, right? So I think a more interesting approach from an attack perspective is leveraging additional native binaries like Internet Explorer and interacting with it through COM object. So this is PowerShell creating a COM object to tell Internet Explorer create an Internet Explorer process that's actually not even spawned by PowerShell. Create a new process, go fetch my payload, and then I will query out whatever elements of the HTML I want and invoke that. Now what's nice about this is that Internet Explorer uses the default user agent string of that system. And in our last example, Notepad making a network connection, that's really suspicious, right? What about Internet Explorer making a network connection? That's its job. That looks not suspicious at all. So this becomes really tricky. So as defenders, are we looking for this? Because we should be. So more obfuscation techniques. These, I'm not going to spend much time on these, but again, basically, you can take your PowerShell command and treat it as a string And there's so many ways you can obfuscate a string. You can reverse the string, like we'll see here. So on the command line, now the entire command is in reverse. And there's wrapper functions that will then reverse that back to normal before it's invoked. You can split the string. You can start to put delimiters in the string and then remove them before you execute the command. You can do that with replace as well. And again, the examples I have up here are using PowerShell syntax as well as .NET syntax to do just that. And a lot of times, there's little things that you don't ever really see being used in the wild, but it's possible. Like for the dash replace, there's actually a -C replace, which is case sensitive replace. I've never seen anyone use that in the wild, but it's possible. So I need to make sure I'm looking for dash replace and -C replace. Again, concatenation. So these are all string level obfuscation techniques. So as defenders, how can we start to identify when this kind of activity? Well, we could start to look for high counts of certain characters, like a lot of $signs for variables or semicolons or things of that nature. However, there's always a way to do it without using those characters. At the very least, if you'll see the bottom of the slide, if there's any character that you know that your target organization is looking for, you can do substitutions. So at the very end, string char 59, that's a semicolon. So now, wherever I need a semicolon in my command, I just put a delimiter, and then I replace that delimiter in memory with my semicolon. PowerShell runs just fine, but again, on the command line, no semicolon. So as defenders, are we looking for whenever we see char casts on the command line? And there's more ways to cast to chars than just that. All right, encoding, decoding techniques. So what do attackers actually use? Really, they don't have to try that hard today. So they typically use encoded command, which PowerShell gives them. And a lot of times you'll see these flags here, no profile, non-interactive, no logo, execution policy bypass. And there's shortened ways that you can write these different flags. These are the most common ones that we see. And there's additional ways that instead of specifying that flag, you can set the same thing in the registry before you even launch PowerShell. We've started to see commodity malware doing this. So let's look at encoded command. These are the most common ways that we see attackers using encoded command. So on the right, if that is our detection, would that catch all these instances of encoded command? And what I mean by that is we see that we're looking for white space, dash, encoded command, white space, right? So this would actually work. This would catch all 5 of these examples. But that's only 5. So how many are there actually? So PowerShell gives us encoded command, and they give us EC. But I want you to look closely because that also works. And that works. Actually, all of these work. Because PowerShell will automatically append a wildcard to the end of a flag when it's doing its parameter binding. So now we have to be really careful with how we're looking for encoded command because there's all these options. This is why for no profile, non-interactive, no logo, you have nop, nani, null, because that's the shortest substring you can have to match on that one flag. Now, in the tool that I wrote, Invoke-Obfuscation, when you are selecting the flags or the arguments that you want, I take this into account. So if you select no profile, non-interactive, no logo, then I will take a random substring every time, completely random, whether it's going to be NOP or NOPRO, and I'll select a random substring. For all of the arguments that you choose, I'll randomize the order, and I'll also randomize the amount of white space in between it. Now, why do I do that? Well, because a lot of tools that are being used today are very predictable. They use the shortest possible flags, and they use the same ordering. So as defenders, we can't become complacent and rely on that always being the case. Because again, this is possible. We have to take this knowledge and change our detection based on it, because attackers can and are using these substrings to get around certain detections. So you can also do base 64 encoding and decoding with .NET. Some different things. Bitwise XOR, Cobalt Strike framework uses this. We've also, I've also been exploring, what about ASCII or hex, octal, binary? These are things that I've not seen attackers use before, but they work. And again, so many options syntactically to do these conversions. And the last one that I explored that was just kind of a fun exercise was thinking about what are other ways I can do encryption or encoding in PowerShell that defenders probably aren't looking for. So I got to thinking, when PowerShell is dealing with passwords, it has what's called secure string. And so I started playing with secure string, and it's actually been around since PowerShell 1.0, and what you can do is you can take a password, convert it to a secure string object, and then if you want to store it like on disk or in registry, you can convert it from a secure string object, and that's what the value will look like. And when you don't specify a key for secure string, it uses what's called DP-API, and the key becomes the current username and the current system name. And that's to make it extremely difficult if you take my password file or value and try to decrypt it on your system. It is possible if you gather additional information off of my system, but it's to make it more difficult to do. So that's using secure string without a key, or without a key specified. However, if we do specify a key, then it's using AES encryption, 16, 24, or 32-bit, and that depends on the size of the key that you pass in. So so that means I can generate a password object on my system, and then you can run it on your system as long as you have the same key. Now here's the great part, is that the secure string object has a size restriction of 65,000 characters. This is code blue. We are security people. We probably feel pretty good about our passwords, right? Who has a 65,000 character password? That's crazy. Why is it so large? What if we, instead of putting a password in there, could put a command or maybe an entire script? So that's what I did. So this is putting just a short command, IEX, invoke web request URL.content. I convert it to a secure string object, convert it from a secure string object to get to this plain text value here. And then on the target system, this is the command that I'll run on the bottom. And I just specify that same key, and this will extract the password, which is my command, and then I invoke it. Last thing we'll look at from an obfuscation perspective is launch techniques. I'll explain what this is and what this isn't, but basically, when it comes to these obfuscation techniques, let's say that we're doing all the right regex, and we're looking for all these things, and we say, anytime powershell.exe runs, we're looking for these strings, and we catch every single one. We're doing great. Well, that's great. If you can figure that regex out, that's great. However, things you need to be aware of. The one thing I won't talk about is what's called unmanaged PowerShell. A guy named Ben 10 is one of the first people I heard about this from, but other people have covered this before me. I'm not going to talk about it now, but the basic concept is powershell.exe isn't necessarily PowerShell. The real heart of PowerShell is this system management automation.dll. So that means that you can have, I can create a new executable that will send PowerShell commands and use that DLL to execute PowerShell on the system, but PowerShell.exe is never run. Now, with PowerShell's updated event logs, you'll see all of that activity in the event logs, but PowerShell.exe never runs. So this is something to be aware of, but this is not what I'm talking about here. What I'm talking about is what are interesting ways that we can launch PowerShell.exe such that the commands, the arguments, don't show up for powershell.exe. So let's look at that. So if you look at PowerShell and just do a PowerShell help, then you'll see that one of the arguments is -command. Then it says, if the value of command is just dash, then it will receive the command through standard input. So what does that look like? Well, this is typically what you see with a PowerShell command, right? Command C, then your PowerShell command. What about this? What if we have command, and then we echo our PowerShell command into PowerShell and say, hey, PowerShell, I want you to execute this from standard input. You can also, instead of the dash, you can use the input variable. You just have to add an invoke operation before it. So both of these are invoking from standard input, and on the command line, that's what it looks like. PowerShell.exe runs, and its argument contains dash, or IEX input. And the actual command, the evil that we're looking for, is in the parent process. So another way that we can do this is instead of standard input, and let me back up. The reason I say that, it's important to know, because if we're only looking for PowerShell in PowerShell.exe, we'd miss that. And there's a lot of ways that you can abstract PowerShell.exe's arguments, not even using just command. You have run DLL, MSHTA, so many different things you can do this with. So it's important to start looking for, from PowerShell's perspective, these launch techniques. Another way that we can do this, and we do see malware doing this, is setting your PowerShell command in a process-level environment variable. So again, command.exe sets the PowerShell command, and then spawns a PowerShell process to invoke the contents of that environment variable. And as you can see, the actual evil command is in the parent process. I'll leave this for the supplemental material. You can do a similar thing with clipboard. You can basically pipe your command into clipboard and then have PowerShell pull the contents out of clipboard and invoke them. So now that we know this, as defenders, we can say, okay, let's look for PowerShell malicious strings, malicious commands in PowerShell.exe, and maybe it's parent. That's not entirely true. So let's look at this example. This is pushing the argument to the parent process. What if we added a third process? What if we had command, PowerShell? Can we get PowerShell's command to go not to the parent process, but all the way up to the grandparent process? And the answer, if you do your escaping properly, because now we have 3 layers of escaping, the answer is yes. And that's what it looks like. So now PowerShell, the command is in the grandparent process. And there's no limit to how many processes back you can push the command. And that's what it looks like there from an outline. So the last thing is, well, what if we recursively check every parent process looking for malicious PowerShell? That's not going to work all the time either. If you can do that, that's great, but there are always ways around it. You can use the clipboard example to have one process set your command in the clipboard, and then a completely unrelated process to query from the clipboard and invoke it, and they don't share any parent process. Another way we have seen an attacker use this is using WMI to basically inject their command into multiple processes and then spawn a PowerShell command to query out all of the command line arguments, piece them back together, and then invoke the command. This is the coolest thing I've seen so far with PowerShell, used in the wild. All right. So let's look at a quick tool demonstration. My only disclaimer is please do not use this tool for evil. Again, I'm not a red teamer, I'm a blue teamer, and I hope this tool helps blue teamers to test your own detection of these techniques. So I'm going to switch over to that now. And again, this is available, it's open source, it's available on my GitHub. I actually just last night released version 1.2 specifically for Code Blue, and it introduces a new obfuscation type. So basically, I like ASCII art a lot, so This is the beginning of the tool. And as you'll see, there will be a menu to help with navigation. And so basically, all the options in yellow take you to a new menu, and all the options in green, which appears a little bluish on the screen, will actually apply obfuscation. So we just type tutorial, and we'll just walk through this tutorial. So first, we're going to set our payload, and this can be a script block, a command, or it can be a remote or local path. So you can actually feed an entire script and obfuscate the entire script. So we'll just set this simple test command just to output a string. To navigate the menus, we have back or cd ... We have home or main to take us back to this home menu that we see down here. So let's go through a quick example. Let's type encoding to go into that menu, and then we'll select option 5, which is in green, and that will apply secure string encryption to our command, and there it is. And you can always type test or exec to execute your command locally just to make sure it still works. You can type show to show you the initial command, all the layers of obfuscation that you've applied, and then the current obfuscated command. Copy, clip to copy it to clipboard, out, we'll copy it to disk. So again, there's our original command, the obfuscation we've applied, obfuscated command, and the length as well is important if you want to run it on the command line. So let's go back to home. Let's reset, so let's remove the obfuscation. And let's find a more interesting command. And this is using the remote download cradle that we looked at in the slides. So first, let's look at token layer obfuscation. So we have all of our tokens here, string, command, argument. So we'll start with string. So again, remember in our example, URL is a string. So we have one option here, and we apply that option, and now our string is concatenated. So let's go back. Let's look at command. Well, in this example, we have two commands. We have Invoke-Expression and new object. And we actually have two different options for obfuscating this, ticks or splatting. So we'll choose number 2, splatting, and now you can see it randomly chose an invoke operator, it randomly chose how to concatenate it, it randomly chose to use single or double quotes. Everything that's possible to do randomly, I've tried to include in this tool. So argument, which we have download string, so we'll choose option 2. Now our argument is ticks. Download string, remember this is a member token, so we'll go into member. We have 3 options, so we'll choose number 3, and now download string is concatenated. And something to keep in mind is that sometimes obfuscation will introduce a new token. So in this example, we obfuscated the member download string, but it introduced a new one, invoke. So you may want to run the tool once or twice just to make sure that you've got all of it covered. So now we have invoke obfuscated. So now every component of this has been obfuscated, and we can run test and see that it works. We can run clip to copy it to clipboard, and there we've pasted it into a PowerShell prompt, and it works. Now let's look at the PowerShell logs, and as you can see, all of the obfuscation is present in the command line arguments itself. And the payload is not obfuscated, but you can obfuscate both the launching command and the payload. So that was kind of complicated to go through all the different tokens. So what we can also do is just have this nice all function, and then just hit 1, and it'll randomize the order and just do all of that for you. And you can do it as many times as you want. And it will keep growing and growing and growing. So let's go back to the home menu. So that was token that we looked at. So now let's look at string. So this basically treats the entire command as a string, and then in this example, we chose 3, which is reversing the command. So now the entire command is concatenated and reversed. Let's reset that. We'll look at just concatenating. We'll reset that, and we'll look at reordering, which uses the -F format operator to chop up the command and then reorder it randomly. And again, you can apply all these on top of each other. Everything you can apply as many times as you want in whatever order you want. So let's remove the obfuscation. Let's look at the encoding menu. And here we have our weird encoding, right? ASCII, hex, octal, binary, and then secure string. And we'll just walk through each option, testing to show that each one does indeed work. Secure string grows very quickly, so it's good to use that one sparingly if you're worried about the size of the command. So lastly, launcher, and this is what we ended on in the slides. Weird ways that we can launch PowerShell to move the arguments outside of powershell.exe. So var and standard in, those will move the arguments to the parent process, and var plus plus and standard in plus plus will move it to the grandparent process. So let's look at var. And for any of these, we can then select any of the execution flags that I mentioned that we want to be associated with the PowerShell command. So we'll choose those, and again, it randomly chooses the substrings for those flags, the ordering, the case, the white space in between. All of it is randomly selected. And so again, if we copy this to clipboard and then run it in a command prompt, which we'll see in a second. And this is just one of the ways that you can invoke an environment variable. Again, the tool has like 3 or 4 different ways that it can choose that syntax randomly every single time. So in a command prompt, we'll paste that command. The command works. And if we look at sysmon logs to look at the command line arguments, we'll see that PowerShell, it contains all the execution flags, but the actual command itself is not in PowerShell. It will be found in the parent process, which we'll see when we scroll down. And again, all the obfuscation is still intact and present. So if we go back, let's remove the obfuscation. If we select one of the plus plus launch types, it will push the arguments to the grandparent process. So we'll go with standard in plus plus. And we'll also randomly choose the standard input syntax, whether that's the dash or the input or anything like that. So we'll choose our flags, generate the command. And I'll go ahead and I'll go ahead and cut the demo short here. There's just 1 more minute left, but to be honest, playing with the tool yourself is the most fun to see how quickly these commands can grow. So this is the end of my talk. And again, my hope is that this is an encouragement to look at what are our detection capabilities, what are our options, how can we break bad assumptions, and how can we look for known bad and obfuscation. How do we look for indicators of obfuscation? Just a thank you to the great people I get to work with who encourage me in this research. And last but definitely not least is my wife, Paige. She really supports me in letting me do all this research, and I'm eternally grateful to her, because without that, then none of this would be here. So, arigato gozaimasu. Thank you very much. I'm honored to be here, and I'll be happy to take questions in the back in the hallway. I'm available all day, so any questions or just to come by and say hello, I would greatly appreciate it. So, thank you.